big, and for them actually it's much easier to control and monitor the overall factory. So here is one of the HMI design. Um, you can see a lot of P and ID is used in this design to show the structure of the plant. This is fuel mixing and heat recovery. So you have fuel mixed and heat is generated and then collected back to the tank. But if you notice carefully, all the numbers displaying here without any measuring unit, or even the pump showing on and off status, but there is no additional information to it. So how to design the better version of it? Do you know the numbers showing here, is it pressure or temperature? Or if it is temperature, whether it is Celsius or in Fahrenheit? So is it if some mismanagement happen by operator due to this kind of design, would you tell this is the mistake of operator or it's a design error? You cannot tell the machine error either. If some machine is unhealthy, then you have no way to know from this HMI design. So our purpose here in this tutorial to let you know how to design a better version of HMI in a way that operator easily can assess the situation and take corrective measures. Okay, you should be asking question why you need a better version of HMI, but you also should ask why you should not, because a little small mistake by operator due to bad design of HMI can cost huge sum of money, and even it costs life, properties, and the company's reputation. That is another factor. Here is some of the points I would like to tell, that what improved HMI can do. It can improve the quality, of the whole operating system, whole control system. It saves time during startup and shutdown and transition, because the information is straightforward, and it saves money by avoiding shutdown, downtime, or error, and also reduce the training time that used to give to operator. And for operator also, it's easier to manage, and the work becomes less stressful. Some of the question you should be asking, why you should buy a better HMI or design a better HMI graphical user interface. Some of the points I have mentioned on the right side is to recognize the problems early and consistently, and respond the problem faster and solve the problem in a better way. Previously, when factories and plants processes become complex, before computer started, a computer actually came into the market. Factories use this kind of monitoring system with the panels, a series of gauges, indicators, and trains, and some light bulbs to display the alarm. But once the computer entered into the market, we saw improvement in the management of the operator station, where analog display replaced by numbers, numerical display. Then in computer, train was difficult, but somehow managed by programming. Used alarms, uh, but that number of alarms increased as the system or the plant logic become more complex. In the beginning, computer had very limited number of colors. I would say it was 8-color display, but there was difficulty because the main color was used as background was black, and to display the plant in lines and PIDs, it was difficult for operator to see the screen from in different angles. So the operator had to sit in front of the monitor, not on the left or right. So there was a lot of limitation. But as the computer system, its ability improved over the time, the HMI design also improved. One question you might ask, what is PNID? PNID is actually piping and instrumentation drawing for graphics. It is used for instrumentation to lay out and install in the plant, but basically this is not for HMI to use. But yes, it gives a flow of the process, but overall it should not be used in the HMI. Partly in some cases, because the process is similar to the understanding of operator, there might be some cases we can use PNID, but obviously it's not case all the time. Do you see any useful information in this PNID equivalent HMI? This is kind of a implementation of PNID in HMI. A lot of things can be in this regard or discarded from this design, like Jackson frame, and the wall design, and then the flooring, and then 3D design, and the tree you see on the right side. These are necessary, but you cannot find the important information like whether the numeric value displays here are pressure or temperature, whether the pumps running or stopped in healthy condition. So a lot of things can be added here to give more accurate information. So when we design, some of the important factors that affect the overall effectiveness of HMI are the standard ergonomic design of the HMI, and then user-centered design, high performance HMI, and then display operator display design, color, the correct color usage. Also, operator has to be trained to operate the HMI, and finally the automation system and the alarms, how they inform operator to take action. So I would say these 3 important points to design a better HMI or SCADA graphical user interface. These vital 3 points to be remembered when designing any HMI or SCADA. The first, data is not information that you need to understand. Put data in context to increase operators' situation awareness. And second point is make it easy by reducing operators' cognitive load. Operator should not be calculating, information or doing mathematics during running of the plant. So it should be very easy to, make decision based on the events on the screen, and build an information hierarchy that's easily navigated, jumping one screen to other screen, from one page to another page, from one part of the plant to other part of the plant should be smooth, and it should be done in easier way. So for this slide, if you notice here, table on the left has limited information, though it has a complete information in the sense the values and result, but you cannot make decision whether these values are within range, whether the value is near, lower side or upper side. So in that respect, on the right side table you see the complete, view situation, whether the values are within range and whether it is on the lower side or upper side. So that's how we actually convert this kind of table into our GUI. And it is even better if you so trained like this, where the values are shown within alarm limit, high or low alarm limit, like this one. On the left trend, you can see a trend is going up and down of a pressure variable. From this trend, operator can gauge whether it is dangerous or make any decision based on these trends. So you see it is going up and down, and it is continuing in that fashion. So operator can take decision when suddenly this behavior is changed, or even can make a call that the process is unstable. Make it easy. The cognitive load is one of the decisive factor when designing a graphic for HMI. On the bottom you see a pump speed is increasing. To display that information, on the right side if you put a small arrow, that's visibly easier to understand, comparatively on the left side that's showing by text. Grouping together data is also important. A part of the plant that is related to one another can be shown into a grouped format, where background color is same, and then on top of the background you display those small instruments and components together in that area, to group them together, to that way operator will understand the situation of that particular group of machines. Keep it simple. So in previous HMI GUI diagram, I have shown the 3D design where the trees and flames are shown. So those information can be clubbed together and shown in easier way. Here it is a better version from the table I have shown. So in the table it is textual, and operator has to read each of this text. But if it is converted to graphical format, it's much easier, and operator in a flash of second he will understand whether something is wrong or not. Another point is when using color, operator has to memorize what color is for what, and there might be difference of understanding from one operator to another operator, and there might be some time when operator is colorblind. To difference this situation, you might use some shape along with the color, like a red with a square, and triangle with orange, and then diamond with yellow color. Even to better this design, you can put a mark inside that symbol. Use of moving things or motion should be very less, very uh, it can be done, but thing is, this should be saved for very important notification, because movement potentially display two things: either it is very dangerous or some opportunity. So one of the example bad way to use motion is to show spinning pump. What is the value by showing the spinning pump? It's unnecessary. And then good way to use motion is to blink an unacknowledged alarm to inform operator that action to be made here. Sound also should be used very scared, very less, and should be used in a manner that it can be turned off by operator. And be consistent. Whatever the design we use in HMI, it should be consistent throughout the whole HMI design, or even it is better if it is industry standard from one plant to another plant, and that way operators get trained automatically. Even hiring one operator to replace another will be much easier, because he is familiar with another plant or something, and those are similar standard. Making easy also by showing graphics, analogous display rather than digital display. Instead of text, showing trained or even the ranges of value with the graphics. Provide feedback. If operator has to enter some value or click a button, show that he has clicked a button to display different color when it is action is is approved or it is selected. When he enters some value, display that value, that what he is entering into the screen. If some value is wrong, outside range, display some warning message. That way operator will know what he is doing. Build an information hierarchy. Operator interface should be managed with at least 3 or 4 levels. But the level 1 should be the overview of the whole design, where the most important and critical alarms are shown, major equipment status to be displayed, and important trend also to be shown. And then level 2, where the second level of information can be shown, where the individual part of the plant can be grouped together, part of the plant like one silo, and related the parameters to be displayed there. And then level 3 is you can show the individual component. If level 2 has a group of pumps, level 3 should be like one individual pump of that group. And level 4 you can include some helpful guidelines, instrument manual, operating procedure, or alarm documentation. So these are the 4 major level, I would say, should be done in HMI, graphical user interface design. Another thing to notice here, from jumping one part of the HMI screen to other part of the plant should be made smooth. If operator has to go back to the main screen to go to other part of the plant, then that's not the right design. From one screen to any screen, if possible, should be made available to operator. So that is called a shallow navigation, because the operator can jump from one location to any other unrelated location or pages. That way operator can take quick decision. Thank you for this watching this tutorial, and I would say this learning about the HMI thing is a lot of patience is needed and research to be done in industry. What is best, and in industry, what is the standard use of color, shape and symbol to be thoroughly understood and implemented, because once you implement HMI SCADA, that is going to be used for a long time. So be careful to choose a certain symbols, colors and text things so that they can survive industrial revolution in near future. Thank you, and see you in the next tutorial.